Hello?
Hello.
Hello, how's it going?
Oh, yeah, pretty good.
Same.
Yeah, the same. Did you go? Did you start studying?
Uh,
You go to university?
As I mentioned, I have have had been there a few times, and now I'm doing that program.
You had been there just a few times, just a few days.
Yes, just a few days, but I think it's enough.
You think it's enough? Yeah.
It's not
Okay.
math is
No
not enough, I
problem.
think. Okay.
But the exams are coming in 3 months.
In December,
In
and
December, yeah, in 2 months.
yeah, in 2 months. But there is no complicated.
Yeah,
There
they are easy for
yeah.
you. Yeah,
Not all of them, but I think most of them.
most of them. Yeah.
But to be honest, I'm reading now physics, but
Yeah.
it's not related to a program because it's first course and I'm third course. It's 5 semester and physics was in the first course.
Oh yeah. So you
I'm reading physics.
everything is fine. Yeah.
Yes.
What is the weather in Kazan?
In rural Kazan, slightly cloudy.
Slightly cloudy. Yeah. Okay. Is it freezing? Is it freezing or not? Not yet.
For me, no, but when time come to evening, coming to evening, um, I think without extra, how to say, kurtka.
Second please in Russian. Что?
Kurtka, how to
Куртка.
say,
Yeah. Suit.
without suit it's going to be complicated, it's cold already.
Today here is raining heavily.
Oh, we
I
have,
was going to go to the countryside, but I won't go because of the heavy rain. It's raining heavily.
we have rain, but it's not was, it wasn't heavy, only slightly sideways.
I still have some grapes to pick up and
Oh,
some apples. I
mm,
made lots of wine and grapes juice.
wow. I think it's tasty.
Yeah, it's nice and tasty.
So that is
Okay, let's do some math in series.
okay, and the page
Can
600,
can you open the book on page 260?
215. Two 260. Okay, I'm here. 216.
Exercise 4.
4.
Write each arithmetic series as the sum of terms, and then find each sum. Exercise 4.
Okay, I see it.
So basically, you need to expand the sigma notation as the sum of 5 terms. That's k range from 1 to 5. How would you expand the sigma notation?
Exercise again.
Exercise 4.
4. They have 5 times. It's repeat five times. To
Oh, no,
come
sorry, it's on page 260
260.
by book, not by file.
Yes,
By
by
book.
book. We have series
From K
from K1 to
to 5, yeah,
yes
yeah.
to 5, And the
Of,
function is 2k 2 times k minus 2.
yeah, just 2k minus 2. So this is the sum of 5 terms. And we plug in 1 to find the first term.
Okay. 5 and k is equal to 1. 2k times 2 times k minus 2. So
2k
we have
minus
to
2.
expand
When
that.
you plug in 1, you get 0, yeah?
Yes.
And then you
And
add
this situation.
the next term.
Next time we have 2 times 2 is equal to 4 and 4 minus is equal to 2.
Yeah.
But where is the formula short?
And you keep going until you reach
5.
until you get the fifth term. You keep going.
To a 5?
Yeah, until you get the fifth term.
Okay, I have the first term it's 8. Then I
The last term is 8. Yeah. So your sum is the sum of 5 terms: 0 plus 2 plus 4 plus 6 plus 8.
yes.
This is an arithmetic series. Shall I write the sum of n terms formula for you?
Okay.
Sn equals n divided by 2 times a1 plus an. This is the formula for the sum of n terms of an arithmetic series.
First term plus the last term.
Yeah?
Okay. I'll write it down. I have to use a red pen to emphasize it. In order to emphasize it. So, series. Okay. Okay.
Right, got it?
Got it.
So what is your answer?
20.
Yeah, it's 20. Now, let's take question 10.
Let's take question 10.
Question 10 is interesting. And I think you will be able to figure it out, to solve it in mind.
Okay, we start from age 1 till age 10 and we just have the first term it's just a 1 because 1 in the power of 1 it's 1.
It's negative 1, yeah.
Yeah, and the last term it's also 1 because always in 1 in the power of 1.
No, the last term is
10.
Negative 1 to the 10th power times 10.
You've got 10.
Yeah. So the first term is negative 1. and then plus 2, minus 3, yeah?
Yes, and then plus, no, the first term is -1, and it's power of, in the power of 1
Yeah,
times
it's
1,
-1.
and it will be just 1, because a number in the any power of, in the any power always positive number.
Yeah, -1 raised to the odd power is -1.
Fourth power. Yes. Because we again times 2 negative number.
So here is what I have. -1 times 1 is -1. And then, when you plug in 2, you get -1 to the second power is 1 times 2. So it's plus 2. And then the signs are oscillating. And you keep changing them into opposite signs. So -1 plus 2, -3 plus 4, and so on. Plus 4, -5,
Okay.
plus, etc. And the last term is gonna be, what do you think? What do you think of the last term? Is it going to be positive or negative? So I mean plus 10 or minus
negative,
10?
I think negative.
No, take a look please. All even terms are positive.
Even or positive?
Yeah, even terms are positive. Plus 2, plus 4. And the last term is going to be even. And that's why we have plus 10.
Plus 10 because it's positive.
Yeah. So plus 10 at the end. And here we've got like 2 sequences. -3, -1, -3, -5, -7, -9. This is the first sequence. We have the first group as the sum of negative odd numbers.
Yeah.
-1, -3, -5, -7, -9. And then there is another sum of positive even numbers. So plus, and in brackets, the second sum. 2 plus 4 plus 6 plus 8. And plus 10. And plus 10.
And plus 10 the last term.
Yeah. The last term is plus 10.
Okay, we're all negative.
What we need to do to find the sum of the terms in the brackets separately and then add them together. So we applied the formula for the sum 2 times.
29 negative.
So here is the sum of the sequence in the first brackets.
Well, we apply the, okay, we apply the formula of that Sn is equal n.
Yeah, the same formula. Yeah, we apply the same formula.
Okay, the same.
We apply the same formula. N equals 5. First term is -1 and last term is -9. So we have 5 over 2 times in brackets -1 minus 9, which gives us -25.
-25.
Okay, so now let's do the same and find the sum in the second bracket. So, got it?
Yep, I think it's 18. I think. So. Lost. No, I think I missed something. It's an N. Okay.
For the sum, in the second bracket, we still have 5 terms. And the first term is 2. The last term is 10. So the sum of 5 terms equals 5 over 2 times, in brackets, 2 plus 10. Which gives us 5 over 2 times 12.
Yeah.
Okay, so the answer is 30. And finally, the sum of the series is the sum of even terms, odd terms, negative 25, plus the sum of the even terms, plus 30. Negative 25 plus 30 is 5. Right, got it, yeah?
Perfect.
You coughing? Got a bit cold?
So, the next question. Okay, we solved it.
Yeah, next question is, let's take question 13.
13. Let's
Question 13.
We have a sum of numbers which start from 0. 13 question.
13. From 3 to 5.
From 3 to 5.
Yeah.
13. Sum of numbers. Okay, is equal 3 and is equal 5. 5 minus 4k is equal. So we start from 3 and 4 times 3 is 12. 12 minus 5.
5 minus 12, yeah, is negative 7.
Is equal to negative 7. It's a first, and the next.
Yeah.
It's 4 times 4 is 16, and 16 minus 5 it's negative 11.
Yeah, negative 11.
So the next is...
And can you see the pattern? What is the next term? What is the common difference?
4.
What is the common difference?
4, I think. In the 4.
Yeah, it's negative 4. Yeah, negative 4.
The next is
so the next term is going to be
15.
Negative 15, yeah. And basically you don't need any formula. You just add them and put the negative sign in front of the sum. So we get negative what?
Okay, we just 26 and 26 is equal 32. Negative.
33, yeah.
33 negative.
We have negative 33.
Negative 33.
Now, there are some very interesting questions. Questions on the next page. Page 261. and questions from 15 to 26. We have to write each series in sigma notation. Okay, let's take question 15.
Okay, 15. Three plus 5 plus 7 plus 9 plus 11 plus 13 plus 15. Okay, we write each series in sigma notation. We have a difference here. Okay, we have numbers from 1, 2, 3, 4, 5, 6, 7. 7 numbers.
Yeah, we have odd numbers, and any odd number can be written as 2n minus 1 or 2n plus 1. And it's up to you.
We have a k is equal 2, I think.
Could be 2, why not? So the sum starts from 2 to
till 7, I think.
Till 8, because we've got 7 terms.
Okay, and the formula here. Say like may 1 plus okay, it's easy formula, but
Can you see the pattern? The numbers are odd.
yes,
So the general term is what do you think?
The general term or the common term here.
Oh, the common term is the same.
Always
they are synonyms. The general term or the common term.
Two.
So
common difference between.
Yeah, the common difference is 2. Yeah, but I would like to know what is the common term or the general term. The term written in the brackets in sigma notation.
I think we can make like 1 plus k, but it's easy.
1 plus k, no, doesn't work. Doesn't work.
Yes, because 1 plus k made.
Doesn't work, unfortunately. But the numbers are odd. Any odd number can be written as 2k minus 1 or 2k plus 1.
2k
minus 1 or 2k plus 1.
2k plus 1. I think 2k plus 1 because we have positive numbers here.
Yeah, but when you start from 2, then the general term is going to be 2k minus 1. If you start from 2, k equals 2, then that can be easily checked. When you plug in 2, you get 2 times 2 minus 1, which gives you the first term, which is 3.
Okay.
And then the last term, plug in 8, and 2 times 8 minus 1 gives you 15. So this is correct. And the same sum can be written in this way. The sum from k equals 1 to 7 of 2k plus 1. This is exactly the same.
If we start from the if we start from the 1,
yeah, we can start from 1. Why not? But we have to change the general term to 2k plus 1.
Okay.
Right, now let's take question 16.
Hmm. 16.
Yeah.
So we go to the 16th question. It's, what is it? Oh, 1 plus 6 plus 11 plus 16 plus
Yes,
3 and
yes.
so on.
That
So
sequence, yeah.
we have a difference in 5, I see.
Yeah, the common difference is 5.
If we start from the 1, isn't
But
it?
you can start from 0.
Yeah,
You can start from 0, yeah.
we can start from 0 and we got something times 0 and it's
Yeah,
0.
something times 0 is 5. 5 times, because the common difference is 1.
I think he's something times and plus 5 when if it's 0.
Not plus 5 times n, 5 times n, and then plus 1.
5 times n and then plus 1.
Yeah. But the sum starts from 0 to 7, I think, because we've got 8 terms.
Yes. So with 7 minus 1 term.
So let's check it.
Minus 1 term.
The sum from 0 to 7 of
7.
5n plus 1. Does it work? Did you check it?
Yeah.
Yeah, it works. Okay, now let's take a question, say 17.
Okay, 17.
Yeah.
We are not going to calc with a sum of sequence. We just left it like it is. Okay, 17.
Yeah.
1 power of 1 power of 2. Okay, we have a sequence which I think it's we have solved something like this already. It's more likely power of 2. Okay,
So what can be seen there? The basis and the exponents are increasing by 1 from term to term.
yeah, we can just start from 1 and go to 4, I think. And the formula is going to be n, for example, or number which is 1 in a power of k.
So we've got equal basis and exponents.
Yes.
And our series would be written in this way. The sum of n from 1 to 5
k in k power of
n to the nth power. Yeah?
yes, k in k power.
N to the nth power. Now, let's take question 20. Question 20.
20. The question is 20. Okay. 1 plus 1 half plus 2. Okay. It's a formula like
all the numbers are powers of 1/2. The first number is 1/2 to the 0 power. The second number is 1/2 to the first power, and then keep going until the last term is 1/2 to the fifth power.
Yes, and it's 2 in the power of... The last term is 2 in the power of 5.
-5. -5 or 1/2 to the fifth power.
The first 1/2 in the 0 power. In the 0.
Yeah.
It gives us 1, because
Yeah.
2 in the 0. So we start from the sum of the k say it's 0, and we go
Yeah.
to
Okay.
the
0.
5. I see.
Yes. 5. Of course. Yeah.
And we have a formula 1 over
1/2. 1/2.
1 yes, 1/2 in the power of k.
Yeah.
So
1/2 to the k's power. Yeah. Here is our series in sigma notation. Okay. Well done. Now let's take question 23.
okay, 23.
Take a look at the denominators. Are they familiar for you?
Denominators, yes, it's 3.
Yeah, they are familiar for you. Yeah, they are powers of 3.
It's always power of 3. 3
Powers of 3.
in the power
But
of 2.
we can see that the signs are oscillating. Oscillating means changing from negative to positive and then keep going.
Yes, I see.
There is another pattern that the numerators are increasing, starting from 1, then 2, then 3, 4, 5, and so on. So think about the formula.
I think the formula is, I think it starts from 2.
From 2, why not? Why 2?
No, from the 1, because
From 1, yeah.
the 2 it's a second already.
Yeah.
Okay, is equal 1 until 4. I see.
Till 5, yeah. Till 5. You've got 5 terms.
Okay, we have 5 terms. Okay.
Yeah.
And our formula is 1 over 2.
1 over 2, no.
No, 3. 1 over 3 in the k power.
Yeah. Yeah,
With
3
minus sign.
in the nth powers in the denominator. But what about the numerator? The numerator is not always 1.
It's not always 1, it's just a k.
Yeah, so k over 3 exponent k. But the signs are oscillating. And you have to write down this factor, -1 to the nth power, to the k's power. So that factor gives you that the signs are oscillating.
Yep.
Okay. And maybe the last question is question 25. Can you see the pattern? In this question, the sum is infinite. It's non-stopping. The sum is non-stopping. And we've got each number in this second power. We've got the sum of all natural numbers raised to the second power. How would you write down this sum in sigma notation? The sum is infinite. It starts from 1 and goes forever.
Yes, we always have. Okay, I just can write it. Say like sum of the k is equal 1 and go to infinity plus infinity.
2 plus infinity, to just 2 infinity.
And the formula just 1 in k power.
No, not 1, n. N squared.
Yes, n squared, you're right.
The general term is n squared. Okay? Now, question 27. Show that.
Okay, 27. Show that eta is equal 1 and n till the n and k times a eta is equal k times sum of number from 1 till n times a.
So basically that property tells you that the constant can be factored out when you use sigma notation. Can be factored out. To prove that, let us write down the first terms of this sequence. So the sum from 1 to n of k times ai can be expanded to k times a1 plus k times a2 plus etc. plus k times an. You can expand your sum to the following sum.
Okay,
Is that clear? What we did, we expanded our sum into the sum of n terms, starting from 1 to n. And then we see that k is the common factor, and we can factor it out. So let's take it out, and in brackets we have a1 plus a2 plus etc. plus an. Okay.
Yeah, we can just factor out k, yes, and it will be same.
And what is in the brackets is sum from k equals 1 to n of ak. So it's sum from I equals 1 to n. So it's k times the sum from I equals 1 to n of ai. Very stupid indices.
Yeah.
ai. Okay, so what we did, we started from the sum of I equals n 1 to n k times ai, and we terminated at k times the sum of I equals 1 to n of ai, which is the same.
Yes.
Okay, now let's take question 29. Question
Okay,
29.
In whatever there are 2 seats in the first row. In the first row, each row has 3 or more seats than the row ahead of it. 3 or more seats. There are 35 rows in the feeder. First row, and there are 35 rows in the feeder. Each row has 3 or more seats.
So we have the following sequence.
Okay, we have
First term is 20. The second term is 23.
first term, second term, 23. And we have a sum of when we start k is equal it's not a 3. 35.
This is the following sequence of seats in the row. And let's find the sum of seats in the theater. The sum of seats in the theater.
The sum of seats.
Yeah.
In that sequence, okay.
So 20 plus 23 plus 26 plus 29 plus 32 plus 35. The common difference is 3, yeah. You're right.
Yes.
So how would you write down let's n starts from 1
Yes.
to how many rows do we have? How many numbers do we have? 6. So n runs from 1 to 6. Yeah, n runs and starts from 1 and terminates at 6.
How we define what terminates from 6?
Because we've got 6 terms. 1, 2, 3, 4, 5, 6. 6 terms. And that's why n starts from 1 to 6. Now, think about the pattern. Since the common difference is 3, we have 3 times times what? Times to get 20.
3
times something and plus 2.
3 times.
Times something plus 2. Okay. Because we need to find such a number n to multiply by 3 and to add 2. Because when you multiply by 3, you get like 18. And to get 20, you need to add 2.
Yes.
So it has to be 3 times n plus 5. 3 times n plus 5. And let's check whether it works. When n equals 1, we have in brackets 3 times 1 plus 5, which is 6. 3 times 6 plus 2 is 20. And what's next? The next term is 23. So we plug in 2. 3 times 2 plus 5 is 3 times 7. And plus 2 gives you 23. So it works. And then you can like expand. So we have the sum of n equals 1 to 6, 3n plus 17. 3n plus 17.
3n plus 17. Okay. So we have, again, let's repeat it.
So the common difference is 3.
3.
And we have to multiply by 3. Now, the first term is 20. 20 is 2 units up from 18. So we have to add 2. And then we need to choose such a number to multiply by 3 to get 18. With when n equals 1, you have to add 5. So n plus 5 times 3 and plus 2 gives you 20. 3 times 6 plus 2 gives you 20. And that's why the expression in the brackets is n plus 5.
Yeah.
You can check it. When you expand, you plug in 1. 3 times 1 plus 17 gives you 20, which is the first term. And then the second term, plug in 2. 3 times 2 plus 17 gives you 23. So that's correct.
Yeah.
That's correct. Okay, let's take number 30, which is very similar to number 29.
Okay, well next it's 30.
Yeah, number 30, yeah.
On Monday, Elena spent 35 minutes doing homework. On the remaining 4 days of the school week, she spent 50 minutes longer doing homework. Oh goodness, 50 minutes longer doing homework than she had the day before. Okay.
So the first term is 45 in minutes.
Yes.
And since she spent 15 minutes longer, the common difference is 15. And we have the following sum. 45 plus 60 plus 75 plus and so on. And then we keep going till the last day of the week, which is the 7th day. Okay, so it's gonna be
4 days.
it's gonna be 60 plus.
No. On the remaining 4 days of the school week, she spent 15 minutes.
6 times 15, 90, 135, isn't it?
155?
Yeah. So we have the following sum. 45 plus 60 plus 75 plus 90 plus 105 plus 120 plus 135. We've got 5 terms here, 7 terms here, starting from Monday to Sunday.
Okay.
And our task is to write this sum using sigma notation. The common difference is 15. And the first term is 45. So let k starts from 1 to 7 because we've got 7 terms. Right. Then, since the common difference is 15, we have to multiply 15 by just by k. Yeah, by k. Oh, it's easy. 15k, and that's it.
K is equal. How many terms we have?
Seven terms because 7 days.
7 days.
Oh no, from Monday to Friday it's written there. From Monday to Friday, so we've got 5 terms.
From Monday to Friday.
Yeah, we've got 5 terms, five days. So our index k runs from 1 to 5.
4 days of a school week. Spend 50 minutes on
5 days, yeah.
Should have it before. Spend 55 minutes doing homework. And 4 days of a school week. 4 days of a school week. Spend 50 minutes on doing homework. The day went before on Monday, and the day before it's one day, but start from 1 day, and 4 days of where it means before plus 1 make. Okay, it's 5 days, and each day should spend on plus 15 minutes. We have k is equal 1 and till 5.
Yeah, to 5, yeah.
Almost 35 plus 15 as I see, and it's a repeat. It's a repeat k times.
Now let's check the sigma notation. K starts from 1 to 5, and the general term is 15k.
15k.
Yeah. So let's expand and check whether we have the same sum as above. So the first term is 15, and then oh no 15. So it's oh that's wrong. That's wrong. 15k plus I think 30.
Yes, 30 was second
Yeah.
term.
The formula doesn't work. 15k plus 30. Let's check this formula.
By plus 30.
Yeah.
Okay.
Substitute k with 1. 15 plus 30 is 45. The first term is 45. Then substitute k with 2 is 60. So it works. And then substitute k with 3 is 75. Plus, when you substitute k with 4, you get 90. And plus 105. So it works. The formula is correct.
15 times. Okay. But try that formula.
Right?
Yes.
The formula is correct. And finally, let's find how many minutes Ellen spent per week for her homework. How many minutes? We have to find the sum of 5 terms. Use the formula.
Okay. Sigma notation. Spend doing homework on the nth day of the school week. Nth day of the school week. Nth day of the school weekend. 10th day of the school.
Did you find the sum? How much time, how many minutes did she spend for doing her homework?
On the nth day of the school week.
She was doing her homework 5 days.
Yes, it's
And,
5 days is first.
She spent 45 minutes on Monday.
And 45 plus 15 on the Thursday.
5 over 2, yeah, 5 over 2 times
Thursday and Wednesday plus again 15. This means 35 plus 15 and give us 16. It's Thursday and plus 15, 75. It's Wednesday and plus
yes.
Thursday.
Yeah, that's right. So we've got the sum of the arithmetic sequence.
Yes.
The first term is 45 and the last term is 105. You can use this formula as we used before. The sum of 5 terms equals 5 over 2 because n equals 5 times the sum of 45 and 105 because 45 is the first term and 105 is the last term, which gives us 5 halves times 150 or 5 times 75, which is 375. So how many hours and minutes? So 375 minutes, which can be converted to 6 hours and 15 minutes. 375 minutes equals 6 hours and 15 minutes, right?
Yes, right. Divided by 15.
Right, I can give you some homework.
Oh, 700.
On page 260. So page 260.
216. The answer were a bit different. Oh, my Skype. It's 6 hours and 25 minutes. 6 hours and 25 minutes. 25 minutes. If we divided 475 by 16, it will give us Yeah.
No, it's 375, yeah.
375.
Yeah, so it's 6 hours and 15 minutes.
6 hours and 25 minutes.
Why 25? It's 16. It's 375.
Okay,
It's 6 hours and 15 minutes.
we can check it.
Yeah, you can check it rest.
Divided by 16. Take it 2 times. Hmm.
6 times 60 plus 15 gives you 375 minutes. Okay? Can
Okay,
you see the screen?
so
Oh, you can see the screen of my mobile. But anyway,
okay. Okay.
yeah, no problem. So, your homework is on page 260 and number 5, 8, 18, 26. That's what we did in our lesson.
Homework.
Yeah, your homework, yeah.
Number 5. Okay,
And see you next Saturday.
and see you too.
Yeah, have a nice time.
Same.
Take care. Bye.
It's strange.